belt scale system consists of a scale weighbridge, calibration weights, a speed sensor, and an integrator. Today we are going to configure the Milltronics BW500 integrator for a typical belt scale application. First, we need to ensure we have the following application information: the conveyor feed rate or design rate, the design speed of the conveyor, the idler spacing where the belt scale is located, the diameter of the pulley that will drive the speed sensor, the total length of the conveyor belt, and the last piece of information we need is the test load value. The test load is the total mass of the calibration weights. Now that we have all of our application information, we can begin configuring the BW500. When you apply power to the BW500, it will automatically display parameter 1 of the configuration. If you don't see parameter 1, you will need to perform a factory reset. This will ensure that all parameter values are restored to factory defaults. Parameter 1 is for language selection. The BW500 can be configured in English, French, German, or Spanish. The default value for this parameter is English. This is indicated by the number 1 in the lower right-hand corner of the display. The V above this number indicates that we are presently in parameter view mode. To edit this parameter value, we press the Enter key. The display now shows an E in the top right corner. This is to indicate that we are in edit mode. Now we enter the number for our language selection. Then we press the Enter key. The BW500 automatically advances to the next parameter. Parameter 2 is the test reference selection. This parameter selects the method that we will be using to calibrate the belt scale. The choices are weight for calibration weights, chain for calibration chain, and ecal. Ecal stands for electronic calibration. In our application, we will be calibrating with weights. Because this is the default value, we can press the up arrow key to advance to the next parameter. Parameter 3 is the number of load cells in your weighing system. In our application, we are using a Milltronics MSI belt scale. This belt scale has 2 load cells. Since 2 is the default selection, we press the up arrow to move to the next parameter. Parameter 4 is the rate measurement system. The choices here are imperial measurements or metric measurements. Our application uses metric measurements. Since this is a default value, we press the up arrow to move to the next parameter. Parameter 5 is the design rate units parameter. Since we selected metric, we have 3 options available to us: tons per hour, kilograms per hour, or kilograms per minute. The design rate for our application is in tons per hour. As this is the default value, we will press the up arrow key to go to the next parameter. Parameter 8 is the date parameter. We will set this parameter to the current date. Press the Enter key to switch to parameter edit mode. First, we will input the year. Enter 2, 0, 1, 1, then the dash key. Second is the month. 0, 6, and the dash key again. Then the day. Press 1, 2. Then enter to set the date. The BW500 automatically advances to the next parameter. Parameter 9 is the time parameter based on a 24-hour clock. The format of this parameter is hours, minutes, and seconds. Our current time is 2:18 p.m. We will set this parameter to 14:18. To access the parameter edit mode, press the Enter key. Enter 14-18, then the Enter key to set the time on the BW500. Parameter 11 is the design rate parameter. In our application, this is 300 tons per hour. Press the Enter key for edit mode, then 300 and Enter to set this parameter. Parameter 14 is the design speed. In our application, the conveyor belt is moving at 0.612 meters per second. Press the Enter key for edit mode, then enter decimal 612, followed by the Enter key to set this parameter. Parameter 15 is the speed constant. The speed constant is the number of pulses produced by 1 meter of belt travel. There are 2 methods of entering the speed constant into this parameter. Press the Enter key. The first method is to manually calculate the speed constant and enter it into this value. The second method is to automatically have the BW500 calculate this value using the sensor data. We will use the second method. Press the Enter key, and then 2. The BW500 automatically advances to parameter 691. Parameter 691 is the diameter of the pulley that drives the speed sensor shaft. In our application, the speed sensor is mounted to a 200 mm diameter pulley. Press the Enter key, then press 200, followed by the Enter key to set this parameter. Parameter 692 is the number of pulses the speed sensor makes for each revolution. In our application, we are using a Citrans WS300 speed sensor that generates 256 pulses per revolution. We will enter 256 into this parameter. Press the Enter key, then 2, 5, 6, followed by the Enter key to set this parameter. The BW500 automatically calculates the speed constant value and enters it into parameter 15. Parameter 16 is the conveyor length value. In our application, the conveyor length is 10 meters. Press the Enter key followed by 1, 0, and the Enter key again to set this parameter. Parameter 17 sets the test load value. The ideal test load value would be equivalent to the material loading on the belt scale. However, the quantity of test weights required would not be practical for this type of solution. In our application, we are going to be using 2 test weights with a combined mass of 16 kilograms. The test load value can be entered into the BW500 in 2 different ways. The first way is to manually calculate the load per idler space. The second method is to have the BW500 automatically calculate the test load using the application data. We will use the second method. Press the Enter key, then the 2 key. The BW500 automatically advances to parameter 681. Parameter 681 is the total mass of the calibration weights. Press the Enter key followed by 1, 6, and the Enter key again to set this parameter. Parameter 682 is the idler spacing at the scale location. Press the Enter key followed by the 1 key and the Enter key again. The BW500 automatically calculates the test load value and enters it into parameter 17. The required startup parameters are now configured for our application.